This is the tutorial number 1 that I'm preparing for the meshing playlist of the software 3D experience. Uh, Keep in mind that the FEA solver in the 3D experience is actually the Abacus program. So these tutorials are useful for people who are either entirely new to 3D experience or they're transitioning from Abacus CAE to the version that's buried inside the 3D experience. Also, should point out that although the software is Abacus, but the icons, the interface, and the feeling is completely different. So it is not to be expected that if you're an experienced Abacus user, you can just get behind the terminal and try to do the same problem in the 3D experience. Okay, so the specific version that I'm using is release 2023x because this is a 3D experience is rapidly evolving and there are I believe, four quarterly updates, and some things may look different. Now, the particular issue that I'm dealing with here is called the partitioning of an object or a solid object that is useful for meshing purposes. Here is an example. Suppose we have a disk like that, and we would like to actually partition this so that it has these features in it. Okay, so I want to be able to, for example, let me put it this way, uh, split uh, perhaps this disk with a surface which actually gives you that uh, outline, or split this disk with a surface that gives you this circular hole feature. The problem is that when you use the split as it is in the 3D experience, which means really Katia V6, uh, you have to select uh, either it gives you two pieces basically. You have to decide on which side you want to keep. Okay. Now there may be other ways, and there are other ways of doing what I'm showing you, but this is how my 2 cents are on this problem. So, as I said, if you create these surfaces and you say you split the disk with that, yes, it'll give you either the left side or the right side. You cannot keep both of them. In spite of the fact that the split in the generative shape design will allow you to keep both sides, in split in the part design will allow you to keep only one of the two. So what we do here is we use these surfaces to create partitions, and that's different from reality splitting partitions, so that uh, it allows us to keep all the sides, and also when it comes to meshing, these can easily be done through the hexahedral or break element meshing, as you will see. Okay. Now, uh, what we need to do to access that partition icon, after you create your part, you go to the meshing module, or what is called the uh, structural model creation. And there, when you are there, before you mesh it, there is this pull-out menu which says model preparation. When you use the pull-out purple, you get into the pull-out preparation icon right there. See that? From here, you go there. What happens is that it tells you, and you try to partition. Okay. Here is the. Let me. I'll come to this thing in a second here. Uh, uh, Notice that when you go to the model preparation, the entire action bar at the bottom changes, and it's right here. And when you look at idealize, there is something called partition. There we are. So it's this thing that you use, not the split. The split is kind of next to it. This thing that you use in order to create partition. Uh, Now, this is very widely used in the Abacus CAE program for creating a good mesh. But now, when it comes to trying to do this, Basically, it tells you, do you want to do this stuff on a part itself or an abstraction? Abstraction is just a copy of the part that you can fool around with it without actually affecting the part itself. I will have a separate video tutorial on this business of abstraction shape, but that comes later. What I'm going to do, I'm going to use the shape itself. I'm not going to do the stuff that I'm showing you on the abstraction. It can be done. It can be applied to the abstraction shape, but I'm going to not go that route. I'll take my part and partition it as it is. Okay. Now, I will do these steps for you later on. When you do the partition, then you have to go to the meshing. You have to exit, obviously. You have to exit that model preparation. You go to the meshing, and the particular thing that you want to do is the partition hex mesh, okay? Because there is something called sweep, 3D sweep. I'll show you. 3D sweep will not allow you to do this thing when it's partitioned, okay? But there's something called partition hex mesh, and that is what you need in order to do that. So what happens is that if you do this, notice that everything is respected. In other words, it's the same thing except I've hidden the part. Here's the circle, here is that curve that I created, etc., and looks like that. Now, the question of layers, how many layers? If you go back there, you see that I had several layers, but you can control the layers, and I'll come to this thing later on, but I want to show you to control the layers. You have to go to the tree, double click on that partition hex mesh. That'll take you to this window. You click on the edit, and then this thing pops up, and there is a line here, there is a seams here. You select that, and it says, what is it, how many layers do you have now? And then you can change that to something else, and you exit, update, and the mesh is going to update accordingly. Okay, so let's go ahead and do that. We'll go to a part, and dimensions don't matter here on that part. On that, I will sketch a circle here, for example, something like that. All right, exit, and we pad. Okay, so let me make this thing a little bit more, so maybe 0.05. Oops, 0.05. Okay, good. Now, I have, I'm using this, the view, so that it also shows you the hidden line. I'm sure you know, if you don't, you know how to deactivate this. In other words, you can go to view, and then you can go to here, display view modes. Yes, yes. And then depending on what you want, you can deactivate that, or but I want to be able to see those, which is right here. I think, yeah. Oh no, right, right there. It's right there. Okay. Let's get rid of that. Now, I'm going to create two sketches. So on this vertical plane, on that, what is that, YZ plane, I will sketch a circle, which later on I'm going to turn it into a surface, okay, something like that. Okay, exit. And I'm going to do another sketch. I'm going to do another sketch, which is that spline that you saw there. Don't do it in the same sketch, because I want to do this thing separately. So on that same plane, vertical plane, I will sketch that spline, which is right here. Yeah, something like that. Exit. Now I have to create surfaces here. So what we're going to do is we'll go to generative shape design, or there are light versions of generative shape design, either way, and you use extrude, and you can extrude these separately. So let me do that. Right now it is 0.04. I'll make it 0.06, and I'll do it symmetrically so that it goes like that. We'll hide it later on, okay? All right, and do the same thing with that circle, with that other sketch. Let me actually make this thing smaller a little bit, maybe 0.06 is what I wanted. Yeah, that's good. It cuts it, you can see that. Cuts it on both sides. And then do another one, another sweep for that other sketch, this sketch. And same thing, for example. That's fine. You see what happened here. Okay, good. Now, uh, because I want to convince you that actually this thing does work, let me apply a material to this. Okay, let me apply a material to that. And I'm going to Tools, Material Browser. It's just a steel, standard elastic properties of steel that I'm going to apply. Because at the very end, I'm going to make an FEA to show you that actually what we did is working. Okay. It was probably easier if I just inputted those things. Oops. Let's try it again. Material Browser. Okay. So here is steel plate. Okay. So I'll just use steel. Apply. What we do is not needing material, but since at the very end I want to do an FEA run, I apply material to that. Okay, it's elastic properties of steel. Let me just make sure. Yeah, elastic, good. Okay, now we're going to do the meshing. So we're going to go to structural model creation. This is where the meshing is done. We're going to use an empty FEA because we will do the meshing together. Okay. And then notice that here I said there is this pull-out menu that you can use model preparation. See that model prep right there? You click on it. Now it says that, do you want to do this on a copy of the part or the part itself? I will just use the part itself because I don't intend to make any use of the shape abstraction shape. So I'll just use the part on the part. There it is. And we say okay. Good. Okay. So now we go to, remember there was an idealize here, and there's the partition. You click on it, okay? All right, it says select the volume to partition, right? So it's this whole thing. And then it says select the cutting element. You just have to put the cursor in there and choose it, okay? Let's do this one first, that one, okay? And then say okay. Notice that if I hide this thing, I see, let me hide this spline also. You see that it cut it. Okay, so another one, another partition, the whole body. For the cutting element, you select that surface, that cylinder thing, and then you say okay. And just to convince you that I actually did it, let me hide that surface, and there we are. Okay, and this, by the way, is the sketch that I drew. Let me hide this thing too. Undo. Where is that sketch that I drew? I can't remember. Was it? Oh, it's hidden. Okay, fine, fine. It did it right there. Okay. Yeah. Excellent. So now let's go ahead and measure. So we exit. Don't forget to exit. See that? Exit app. This was the app that we got into, model preparation, simulation model preparation, right up there. So exit that. We're back into meshing. Now what I want to do, I don't want to do the tetrahedral element. I can. This is tet element. I want to do the one that says partition hex mesh. Now notice that there is also this sweep one, but if you try to do that, it will not work, okay? But so if you have a partition one, you go to right there. You go to partition hex mesh, you select it, you select the part, This is the rough side. Now, I don't know, this was 0.06. This is going to be a very coarse mesh. So actually, let me do the following. Let me make this thing, put another 0 here and see how it looks like. 0. Because remember, this whole thing was 0.06. Okay, this thickness was 0.06, if I'm not mistaken, or something like that, 0.04. Now, this is right here. We can fool around. We will fool around with these later on. Okay, you say mesh. I think that's a very fine mesh. So I'm going to change that. That was a bad idea. It was a very small number. So I'll make it 0.01. See, that's so right there. Okay, so I don't want that thing. So let me make it 10 times bigger, 0.01. Mesh it again. There, good, good. Notice that the the mesh actually follows. If you look at the front view, this is where the cut was made or the split was made, and this is where the split was made. So it actually worked. You can see that. Maybe I make it a little bit smaller, maybe 0.01. Good. Now, let me double click on this. Let's double click on this again because I want to show you something. Next line. Oh, not here, sorry. Expand this thing here, partition X mesh. So, first of all, it is linear because this is checked. This was linear, this is parabolic. Uh, oh, I'm sorry. This is a combination of both hex only, and this is hex dominant. Okay, this is hex only. I mean, you may or may not be able to do something that's but anyway, I use hex dominant. Okay, you can see that. But what I was going to say you is that notice that there is arbitrarily put the what is that four layers here. See that? 5 layers here. And we're going to change that to 1 later on. But let's keep it the way it is right now. Okay, so that's fine. The mesh is made. You can see that. And let's go ahead and, for example, go to apply. So let's restrain these faces and apply a pressure on this side. Incidentally, you can also cut uh, the object with surfaces may be planes. In fact, you can use x, y, x, z, y, z planes also. Okay, so any plane will do. Okay, will do also. All right, so let's go ahead to structure model, structural scenario creation, because I'm going to do a very simple linear analysis. So that's all static analysis. Okay, we're going to do structural, and for the mesh that we created. Good. Let's do a procedure, and the procedure is static, and I don't want any nonlinearities here, so I'm going to go to advanced, uncheck the include geometric nonlinearity. Good, so it'll do it in just one shot basically. And then let's go to boundary conditions and clamp, for example, clamp this circle, and we can do that because we created the partition. And that circle, these two surfaces are clamped, and let's apply a pressure on this side, for example. So under loads, you're going to apply pressure. The actual numbers don't matter here. I just want to show you the process. So I put down 1,000, I don't know, Pascal, right there. You can see this, okay? So that's pretty much it. Let's go ahead and run it. We go to simulate. Let's check, make sure there are no issues with the model. In case you something trivially you forgot. In fact, we did, and I know what happened because I forgot to apply the properties on that solid mesh. I created the mesh, no problem. It's just the properties I didn't do. Where do you do that? You go back to the meshing. You go back to uh, back to the Back to the model, that's fine, no problem. Back to the model. Under properties, under solid properties, you select this entire part. You can do it from the tree, and notice that the properties of the seed is put up there. We didn't have it before. Now we're done, so we go back to scenario and run it again. You can see the value of this model check, model and scenario check. It told us there was something wrong here. Here, this is simulation check. In case there are issues with your load and restraints and things like that. I don't anticipate any problem. I'm going to run. And it's just going to take a single increment because I unchecked the include the nonlinear geometric effects. We'll do it in just one shot. A simple linear analysis. Okay, simulation checks completed. So close that thing. Now we're going to run. This is the actual run. Simulate. Incidentally, there is another good tutorial on partitioning issue, but it's kind of an old one. It's by PLM Technologies, okay? So if you go to PLM Technologies link, there is one where this partitioning is explained a different way. That fellow is using an abstraction, which is fine. So close it, and if you look at the next, this is the initial one. There we are. So it does work. It did work. You can see that we clamped these. We apply the pressure here, and look at the displacement, for example. Yeah, this deforms or moves as much because we put the pressure over here, and these were fixed. Okay, good. So this we got the picture. Now I want to show you how do you go about actually changing this. Okay, in other words, instead of 5 layers that we had, how do we go about changing it? Okay, so here is what we're gonna do. Uh, if you look on the nodes and elements, double click on this partition hex mesh. Okay, this thing pops up, and then click on this edit. Edit. Okay, just give it a second. This pops up, and there are different things you can do here. For example, if you say this, just show me the geometry. Okay. So notice that with this you can control what is being shown or not. The one that I clicked on is this, which shows you the seeding. Okay, and I don't want to see the geometry, so let me hide this. I don't want to see the mesh. Hide that. Okay. It showed you the seeding, and notice that in the length direction, uh, the ones that say, for example, here it says, what does that say? 6. So 1, 2, 3, 4, 5, 6 in the length direction. You want to change this thing to 1, 2, 3, 4, 5. You want 2 in this length direction. Okay, 2 nodes or 1 node. If you want, for example, uh, let me see now. When this says 5, these are 5 elements. Okay. There are 6 nodes here, so I want this thing to be 1. So here's what I have to do. I click on the edge distribution right there. See that edge distribution, and I will select this one, that one, this, that, and that, and there's one more here. So these are the 6 edges. Basically, show you the extrusion in this direction. Okay, and I want only one. I just want one element through the thickness. And we say okay. Okay, notice that these all change to 1. See that? The ones that is in this direction. And then you exit and update. One element through the thickness. Let's say you want to change this thing back to, let's say, change it to 2. So here's what we're going to do. You double click on the mesh distribution, mesh specification, okay, and uh, edit parameters right there, or edit basically, okay, and you click on the seeding. The other option is just double click on this, okay, double click on that. It says there are 6 edges that you pick, and you said you want one element through the thickness. So here's what I did. I double clicked on this. It says these 6 edges, you told me there's in one element. So let's make this thing 2 elements. Say okay. Exit. Update. There we are. Let's say that we want, for example, more elements along this edge. So here's what we're going to do. Now, obviously, we don't want to. Let's double click on this guy. Double click on partition hex mesh. Edit parameters. Okay. Notice that we already have specified the edge distribution along this direction. Now I want to do it around that circle. Okay, so what we're going to do is we're going to create another edge distribution right there. It says which ones, which edges. I want this edge and that edge, 2 edges selected. And let's say we want maybe let's make it 20 along that. Right now, I mean, basically you have to count how many elements you've got here, but let's make it very fine, 20. You say okay. See that? It changed it. Exit. Update. 2 through this, a lot more through that. Okay. Let's say we want more elements through this length. Okay. So here's what we're going to do. We're going to double click on partition hex mesh. Okay. Edit parameters. We want to create another edge distribution, and it's this edge. Okay. And we want, let's say, 40. I'm sure there's less than 40 here. We say okay. Uh, exit and update. See, there's a lot more elements through this. Let's change the length one more time. So the length in this, the number of elements in this direction had to do with this first edge distribution. Double click on it. Oops. First you have to double click on the partition hex mesh. Edit parameters. It was this one. Let's make this thing 15. So through the thickness 15. You say okay. Exit and update. There's going to be a lot, 15 elements through the thickness. You can see that. All right. So that shows you how you go about creating a partition, controlling the number of elements through on a particular edge. Okay, those edge distribution, and of course the global mesh size was already set at this level right there. Okay. So because when you put a number here, it has its own mind. It's going to create something for you, and then you can go and change it. All right. Let me see for a second. Let's keep this thing right now. Remember, I believe I had 15 here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14, 15. Let's change this thing to 0.05. See whether actually change that one also. See, it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14, 15. And the reason is that for our mesh, if you go here, that first one is still, well, if you can reach it from here, double click on partition hex mesh, click on edit parameters. Now you can go here and click on the first one. Instead of 15, let's say we make it 1. You say OK, exit, and update. 1 through the thickness, and that small number 0.005 everywhere else. All right, folks, good luck.